when we combine multiple security association, what we do, we create bundle. What is a bundle, Fahad? When we have multiple security association combined.
So this is like يعني like round example with encryption,
Yeah,
right?
you can say. Okay, here
Yeah.
on the lower side of each diagram we show physical connectivity, and we have host. Host can be your workstation or servers, and otherwise we have security gateways or routers over here. Now this look show a security association bundle between two hosts. So between two hosts you can have a transport mode or tunnel mode, any mode you can use, but preferably we use transport mode, but because tunnel mode has no added advantage over here. And you can combine AH or ESP on it. And here if you see case 3, between host you can have transport or tunnel any, but between gateways you always have tunnel mode. Okay, or between gateway and host there is a tunnel, gateway and host tunnel mode. Only host to host you can have transport mode. Between two gateways, or even if we have one end as a gateway, like here one is host and one is gateway, you will have tunnel mode. Between two gateways you have tunnel mode. Okay, and it is possible that the endpoint is more than one, like here this tunnel has endpoint this security gateway, but it has further this and it has endpoint over here, and here we can have maybe another tunnel, and inside this tunnel maybe we have a transport.
Yeah.
Okay, internet key exchange, that is the key management protocol for IPSec. So this key management protocol is responsible for distribution of the keys that will be used for encryption or MAC calculation. So they said that a typical requirement is 4 keys for communication between two applications. Very interesting. A 4 key for communication between two applications. Transmit and receive pair for both integrity and confidentiality. As I told you, if we want between two hosts, let's suppose both way secure communication, which is not only encrypted but also authenticated, you will need how many security associations?
4.
4. And each security association you will need one key, huh? So you will need total 4 keys,
Uh,
one for encryption and authentication on one side, and one for encryption and one for authentication on other side. So total 4.
and these keys are symmetric or asymmetric?
This key will be distributed through internet key exchange protocol of
Symmetric.
IPSec. Now there are two ways to distribute keys. One is manual and one is automated. Now manual is this, like your system administrator will manually configure each system one by one and write or store key over there. It is good, but it is simple. But if we have a small scale network or small scale environment, we have only 2, 3, 4, 5 systems. Okay, we can do it manually. But if we have a large scale um, system or a network, then manual key distribution is not an option. For this we need automated. So IPsec provide both option. You can go for manual, you can go for automated. For automated, it will be created when it is required, on demand. Okay, and for large scale networks we always prefer automated, because manual will be very cumbersome for it. Okay, so the default automated key management protocol for IPsec, we call it, is a KMP or Oakley. Okay, it consists of two further, like internet key exchange protocol consists of two further protocol, Oakley key distribution and is a KMP. Oakley is a protocol which is based on Diffie-Hellman algorithm, because we know that Diffie-Hellman is the first public key cryptography algorithm that is used for key distribution. But it also provide extra security it's not using Diffie-Hellman as such, because Diffie-Hellman has a problem of man in the middle attack, but there is no man in the middle attack when we are using it in Oakley key distribution, because it added some more security features to prevent it. Oakley is generic in that it does not dictate any specific format. The other one is a KMP, or Internet Security Association Key Management Protocol. Uh, this protocol provide a framework for internet key management, and also provide specific protocol support. Like Oakley is a generic, but this provide you a specific protocol support, including format and negotiation of different security attributes when key exchange occur between sender and receiver, or between two parties. Okay, these are the features of IKE key determination when we use it in IPSec for key management, whether we are using Oakley or is a KMP, both. By the way, we have two version of IKE protocol. IKE version 2, we don't differentiate between Oakley and ISA KMP. We just call it IKE version 2. But IKE version 1, there was two flavor of it. One is for Oakley and one is for ISA KMP. But the new version is IKE version 2, which do not differentiate this Oakley and ISA KMP. Basic functionality for it is same. Okay, now what are the features of IKE? First one is it use cookies. The purpose of using cookie is to prevent from clogging attack. Now what is a clogging attack? In clogging attack, attacker forges the source address of the legitimate user and send public key to the victim, and then victim will start computing the secret key, and attacker will send repeated message of this kind to the victim, and victim will keeps on using its all the resources for calculation of the secret key for that public key, and like a denial of service kind of attack. Okay, so a lot of resources on the victim machine is just wasted in calculating this secret key. So this attack is called clogging attack. How to overcome this attack? To overcome this attack, cookies are used. So it use cookies for that. Then it enable the two parties to negotiate a group, because they are using Diffie-Hellman. So when I did not teach you Diffie-Hellman protocol, but when we go for the cryptography of Diffie-Hellman protocol, there is something that is called a group, that is part of public key of Diffie-Hellman. So both parties need to first negotiate on this group for key exchange, and it uses nonce to ensure against replay attack. Nonce mean random number, so it uses random numbers so that to prevent replay attack. And it enable the exchange of Diffie-Hellman key values, and also it prevent man in the middle attack. Diffie-Hellman, there is a possibility of man in the middle attack, but in IKE it authenticate Diffie-Hellman exchange so that man in the middle attack should not be possible. Okay, these are the messages.
Yes,
Yes.
Doctor. What is cookie?
What is cookie? Cookie
Yeah, like
normally what is a cookie? Cookie is the concept that is used by website to keep track of the user activities, because HTML is a stateless protocol. If you go and visit some website, server will not remember it. Okay, it is stateless. Server will not come to know what did you do on this website in the last time when you come over here. But you see, when you go to Amazon for shopping, and when you go next time, it recommend you products. If you go to YouTube next time, it recommend you videos. How it recommend you these things? through cookies. Cookie is a mechanism that is used by website to keep track of online user activities. So here they use this some okay, cookie is what is a random number that is stored on the other side and all that. So here they use this concept of that random number and how cookies are used to prevent this clogging attack.
Okay. Thank you, doctor.
Okay, we will not go into the detail of IKE protocol, but here just I will give you a rough overview. First thing in IKE is that IKE exchange occur in pairs, like sender and receiver. This is called one pair, another pair. So first process, that is called initial exchange, we complete it in two pairs. Okay, so in initial exchange, both parties, initiator and responder, they exchange information regarding the algorithm that they are going to use and other security parameters they are willing to use, along with nonce and what Diffie-Hellman public values and groups they are going to use. So all this information is being transferred between both parties in the first exchange, and the result of this exchange is to set up a special essay that is called IKE essay. So this essay define parameters for secure channel, like which keys will be used, which cryptographic algorithm will be used, what public values for Diffie-Hellman will be used, and all that. And all coming IKE messages are then protected by encryption and message authentication. So after initial exchange, a security association has been created between initiator and sender. Then there is a create child essay. That is a second exchange. In create child essay, both parties authenticate one another and set up their first IPSec essay to be placed in security association database, and then use it for this information exchange and all that. Like here, they share keys and all that. Until here, they just authenticate each other. In initial exchange, they just agree on the cryptographic algorithms they use, what Diffie-Hellman parameters they are going to use, and both parties authenticate each other, and then they share proper keys with each other after that. And then a first child essay has been created, and whatever keys they share over here for the subsequent messages, these keys are used for protecting that information for authentication and encryption, and that's all. IKE is very complicated protocol itself. It takes like another complete lecture on it if I want to explain this thing. So we just go through it like summary. Okay, this is the IKE header format. You can see that we have SPI, initiator security parameter index, responder security parameter index, and we know this. What is this SPI? Then we have what is the next payload after IKE, major version and minor version of IKE that we use, exchange type, flags, message ID, and length. Each message has its own message ID, which tells you what type of message it is, because we have different type of messages. And that's all. Next, these are different types of IKE payloads that are available with IPSec. If you want to go for more details of it, you can go through it from the book. These are payload types. Then cryptographic suite for IPSec, like it support 3DES in CBC mode. If you are using VPN A and VPN B, you can use this RFC for creating virtual private network. Two types, A and B, for both different cryptographic algorithms that are being supported for encryption, integrity, and all. These are given over here. Okay, this is NSA suite, and this is VPN, and that's all. Chapter finished. Alhamdulillah.
Thank you so much.